Hey everyone, welcome to this channel. Today we are talking about one of the most important tools in the modern software development, that is Docker. Usually, when you are working in your startup or a college student working on some college project or in software industry, you might have come across that a developer says that it works on my machine, with the other developer or the other person saying that no, it's not working on my machine. So if you ever come across that kind of scenario, then this video is for you. In the next 10 minutes, I'll walk you through exactly what Docker is, why it exists, when you should use it, how it actually works, and its core components and architecture, and also a real-time example, and also some of the basic commands that generally use, which are required for a developer that regularly they use. For this video, no prior Docker experience is needed. Let's get started. And so here, let me, the next slide we have. So what exactly is the Docker? So if you see that, let me take my pen. So if you see that Docker is a platform that lets you package an application along with everything it needs, be it the code that written by the developer and the libraries that are required. Let's say you are writing a Python application and it is having different version like Python version 3.1, 3.2 or 3.10 or 3.10, 3.14, etc. So and also the dependencies like anything that come across for the application to run, and the different libraries that are required, like, and the different settings that are required. So everything in a single unit, you put it in a container and you run it any mission. So so basically, so it lets you pack your application along with everything that it needs to run the application. So once the container is built, and that's it, your application can run in anywhere. No more things like, it was working on my machine, not sure why it is not working. So think of it like a lightweight portable box for your application. Uh, and let's move on to the next slide. Why do we need Docker? Because of its consistency. So if you see that, if you see that uh, consistency, the first thing, uh, it works as it works like across all the development, the test environment, or even production environment. It's work like that only everywhere. So it doesn't matter like where your app is running, like isolation. Each app runs in its own container without any conflicts. And speed, once you containerize your application, it's very fast than the virtual machines. And then finally, the portability. Once you containerize your application, you build it once and you can run it anywhere, be it your personal laptop or your friend's laptop or on a server or in a uh, uh, their own company's own servers or the cloud like AWS, Azure, or GCP, any application, it will work exactly. Let's take a real-time example. So in the maritime, like if you know that they have to from one country to another country, how the trade used to happen is they used to send all the loose goods to cargo, and the commodities are might be in different shapes and sizes, could be loaded by hand, and there could be some spillages, and once it reaches a destination, you may not sure like what has been originally sent and what is currently, and it won't be exactly. And and later from every ship and to truck needed to custom handling every time. It's a slow and error prone, right? And then later people come up with steel box called container. You might have seen. What this container does is once you put everything into that steel box, you can ship that in a ship or a train or a truck. Once you containerize it, no matter where it is going, what is inside, it goes smoothly. Exactly. Docker also does the same thing for the software. Your app and everything it requires, and you put it in a standard container, and that will run anywhere, everywhere. Your laptop, your team's laptop, or anywhere, it will work exactly. And when do you use your Docker? So when should you use exactly the when you should uh, actually reach the Docker? When you want to share the app that runs identical for everyone, right? This is the one. And the next thing is when deploying microservices, each microservices in its own container. See, modern development, software development would be developed on the microservices only. Earlier, apps are built with a monolithic. Now, monolith apps. Now it is changed to microservices way back. See, I'll make a different video on monolith applications and the microservices. What is the pros and cons. Even microservices also have its own cons as well. Recently, Amazon Prime Video company, which is related to Amazon, they also changing back to the monolith. Why? We'll talk about it later. Now, for now, understand that even microservices also have their own containers. Once you put each microservices in one container, it will work everywhere. And then when you need quick disposable environment for testing, so for testing purposes, you might have, generally in software industry, you might have many non-prod environments like developer environment, testing environment, we call it as staging, pre-productions or prod copy, and then later production. For quick testing purposes, you can quickly pull the container and you run it, you test it, and then you can dispose it. And then the next point is that when you're moving your app to the cloud like AWS, Azure, and GCP painlessly. Since you containerize your applications, very easy to ship your application into different platforms. And when onboarding to new developers, see, when the new developer joins your company, what you usually do is you have to configure his laptop first, configure with your application so that he can start working on his assigned feature or assigned task he will work. For that, he needs to get the required packages, libraries, everything in his laptop. He has to run the app first. So for that one, Docker is the first place to go to get this done. And how does the Docker works? And this is the way. So first, there would be one Docker file where you write like what is the application, which software you are using, what version it is, and then different dependencies, libraries that are required, everything you put it in a Docker file. And then there is another thing called Docker image. It's actually a blueprint. Whatever you written in the Docker file, that would go into the Docker image. So basically, when you are constructing a house, you make a blueprint that how exactly the building should be. This is exactly like that. And then finally, there is something called container. So this container is a thing where this container is a thing like where your app is running, your app instance. And finally, you write the Docker file, and Docker builds an image from it, and then you run the image on your computer. So that's the thing. Now let's move on to the next component. These are the core components in your generally in uh, Docker. So when you uh, so this is the thing like uh, the building blocks of the Docker file. So the first one is a Dockerfile, where this is a text file as I mentioned before. This would be having steps to build the image. And then once that is done, there is another thing called image, Docker image, where the read-only template, which is related to your app, which we have written in the image file that we have. The next thing is Docker container, where this is the running instance of an image. And the next thing is Docker engine. So Docker engine, the background service that does all the work. So here what everything this is the heart of the Docker, I can say, the background service that builds and runs the container. The next thing is Docker Hub registry and online storage that share and pulls the image. So this is the one. This is the Docker Hub where all the Docker containers that are developed or created by the different companies that can be available here. Let's say if we search for Python, you can get lot of things that are lot of containers that are built by the different companies. See, this is official Python thing which is updated recently, which is having 10 million. Another one is Python which is having 1 billion, which means 100 crores downloads happened so far. So when you click on it, you would be able to see this is the container. See, Docker official image. So interpreted so sorry, I said container. It's actually image. Once you download this and you start running, then it's called as a container. And there is we talked about this online storage to share on the pull the images. The next thing is volumes, a persistent storage outside of the container life cycle. Say for example, so you stop the container. Later you want to see what is in there. That time this volume helps you. So for saving the data even after container stops, that purposes we use volume. We will go through all these things. So this is the real-time example that I can quickly show you that with a small Node.js website. So here is the one. So the first thing is from I'm using Node version 18, and then here is my application code that I have written that I'm placing, and I'm copying it from my source, and then I'm running the npm install so that it can install the required libraries, dependencies, etc. And then now anyone can and I'm exposing it to 3000 in my browser, so it in the port, so it can run in my browser. And you see, that's it. So this tells the Docker to start the Node.js application that I have built. So copy code in, install dependencies, and then run the app. Now your teammate, server, or a cloud, anywhere this app can run smoothly. Let's move on to the next slide. Who are using this Docker in real time? Every software company, I can say. Many services companies also use Docker. So, for example, I can say this: Netflix and Spotify users to run their microservices at scale to stream reliably. And the next thing is that PayPal uh, uses containers to ship the payment services faster, more reliably, and the startups, students for their college projects, and every developer teams that works on like to spin quickly a database like MySQL, Postgres, or MongoDB, or anything. Without installing locally, you can directly run it using Docker for your application. And then this is the simple architecture that I can show you. Like you run a command, you run a simple command like a docker run or a docker build. Docker daemon. Daemon is also called as a docker d, where which does actually the work, pulling the images, creating the containers, and those images whatever run, you are bringing from the Docker hub, that will come to images, and then you make it as containers, and then later you work on it. Later you can push it to Docker Hub as well. So they become as containers later you can work with. So that's how it works. You give your command to CLI, that daemon does the work, and images begin your running containers. So the next thing here are these are the 5 commands that, yeah, I can think that you require to work in your generally say that I know the Docker. So these are the constantly used, constantly used in everyday to work. The first one, Docker version used for which Docker version you are using. So the next one is for pulling this nginx is a image. So we use this Docker pull nginx to download the particular image, and then Docker run to run the particular containers. And also you can see using the P, you can see that which version to listen, like which containers are running. And then later you can pause it, you can see how what are the other containers running, and using stop command you can stop the container and whatnot. These are the to get comfortable with these 5, you are already ready to work in the Docker. And the last but not least, the summary. Here is the summary, like Docker packages your app and portable into portable containers. It solves the issue, like it's working on my machine. I'm not sure why it is not working on your machine. That kind of problem it will quickly resolve. And this is fast, lightweight, consistent, and cloud ready. So once you build the application, you can ship it and run it anywhere, everywhere, wherever you want. Finally, the last slide. This is all about, that's the Docker in a nutshell. If this video helped you to understand better, hit the like, subscribe, and try running your first. Try installing Docker in your machine first, and then try running the basic commands which I showed here. So that's it for today. We'll meet in the next video.